In today's lesson, we are going to talk about how to design for inheritance for class hierarchies. Inheritance is often described using a tree diagram, and the reason why we do this is because it makes it very easy to show a parent-child relationship. In this diagram, we show you that a child class can also be a parent class. For example, this element right here is a child to the one above it, and it is a parent to its children below it. So it is not limited to just one layer. And if we have two or more classes that have the same parent class, then they are called siblings. And these sibling classes are going to inherit and share the same parent properties. Other than that, they are not connected. It is possible that one object can exist without the other. When we are designing classes, there are a couple of things that we want to really try to drive home. One of the biggest ideas to remember is that we want to have the common properties at the highest level possible. And we do not want to redeclare instance variables. So for example, if we were having a set of classes to describe animals, and then we were going to have a subset or a subclass, so let's say we had animals, and then we had a subclass called pets and zoo animals. And then within that, we had a subclass of, small and large. So we have small pets, we have large pets. Well, in this case, if one of the animal's traits was a name is something that all animals would have, whether they are a pet or whether they are a zoo animal. Pretty much every time an animal is owned by somebody, it's given a name. So it would make sense for this name to be given at a higher level. Now, let's say, for example, this animal class was going to also have a subclass called wild animal. Well, animals that exist in the wild don't have names. I mean, at least not that we know of. I don't know, maybe they do. But so if we were looking at a structure like this, well, then it wouldn't really make sense to have name declared up here for animal, because maybe not every single subclass would have a name. Maybe that would just be declared in pets and zoo animal. Or maybe we would name this superclass domestic animals or something. But these are different areas we want to think about when we design our classes. And the nice thing about inheritance is this trickle-down effect. And what this means is that changes made in the superclass immediately trickle down or change for the subclass. And inherited features are passed all the way down the levels of the hierarchy. So let's say we had, for example, the mammal class. And then of the mammal, we had four-leg mammals, and then of that we had dog, and then of that we had retriever. I don't know. And if we think about a trait that is common of a mammal, for example, breathes out of their lungs, then that is also true of a retriever, because a retriever is a mammal. Now, if there was a trait that a retriever had, that doesn't mean that every single one of these animals also has it, because these animals are not all retrievers. So as we go down, we become more specific, and as we go up, we become more generic. And you want to be able to put common properties as high up as possible. And by doing so, you can have the code that you write affect as many classes as possible at a high level, meaning that you have to write it in less places. Okay, if we look at this example that we see here we have a vehicle superclass. And vehicle is a pretty broad term. There's lots of types of vehicles. And so we have land, water, and air. And then in each of those subclasses, we have two more subclasses: car, bus, ship, boat, aeroplane, and aeroplane, that's interesting, and helicopter. So when we look at this, we can see that the class that is directly above it is its superclass. The class or classes directly below it are its child classes. And then if two classes have the same parent, they are siblings. Also notice that the more you go down the chart, the more specific you get. And then the more you go up the chart, the more generic you get. Okay, so if we want to have superclass to water, the superclass to water would be right above it, which would be vehicle. All the subclasses to water would be the two classes below it, ship and boat. Relationship between car and bus have the same parent, so they are, I can't spell. What else is new? Those are siblings. And then the relationship between car and helicopter, they don't really have much of a relationship. I mean, some people would say they're cousins, but they're both vehicles. But other than that, they are very loosely connected. So the only traits that they would have in common are traits that were inherited from the vehicle superclass. All right, now first semester we talked a lot about the object class, and we talked about how every time we created a class, that class was automatically a subclass of the object class. And at the time, you might not have quite realized what that meant. Well, that is like, as it says here, the top dog of the food chain. This is like the end-all, be-all, where it all begins, okay? And every class that we create extends off of the object class, so much so that we don't even have to say it. Okay, now any object we make automatically inherits these two methods, and that is why we have gotten used to creating our method equals and toString. And the way that the classes will overwrite these methods is often based upon their individual needs. So how are two objects equal? What does it mean to make them equal? How do we want our objects to be printed? And when I say printed, remember that our toString returns a string. So if the object is called in a print statement instead of printing the object's address, if there is a toString method, the toString method is called instead. Now, another topic we're going to talk about today is abstract classes. We talked about abstract methods before, but now we're going to talk about an abstract class. And a good way to think of this is that it's kind of like a ghost class. It can pass along methods and variables, but it can't ever be instantiated, just like an interface. Unlike an interface, it can have methods with implementation, instance variables, and it can be used for planned hierarchy. So a good example of this would be, let's say you know that there's going to be a lot of characteristics of classes that are going to be the same, and so you can set up kind of like a skeleton superclass, and there's some methods that you can write that will definitely work appropriately for the subclass, but then there's other methods that you just can't write. The subclasses have to provide their own implementation for those methods. And so those methods would be abstract, meaning that there's no code in them. And if your class has one or more abstract methods, then the whole class is considered abstract. Okay, so if the class has one or more abstract methods, then the whole class is abstract. Now, fun fact, it doesn't have to have any abstract methods to be abstract. You could just declare the class abstract. So let's say you don't want anybody to instantiate objects of a certain class. Maybe it's not meant to be instantiated. You could just declare it abstract and nobody can instantiate it. So why in the world do we want to have abstract classes? Well, they're good for a couple reasons. First of all, they're really good for placeholders in a class hierarchy. You can create partial descriptions of what is inherited by all subclasses, and this also provides subclasses to, this forces our subclasses to provide implementation for specific methods. And by doing so, we can force these subclasses to provide code for these methods so we know that they will have the desired functionality that we want. They will be called what we want, and so we know that they'll work correctly. Here's a good example of an abstract class. If we look at the vehicle class we just talked about, the instance variable of speed, all vehicles have speed, and then there are some methods that all vehicles would have in common, for example, move or fuel consumption. And then some of the subclasses are vehicle. Whoopsies, didn't mean to do that. Some of the subclasses are vehicle that we had were car, boat, and plane. And they're going to have these same method names, but they're going to use their own implementation for these method. So for example, the fuel consumption of a car and a boat and a plane are going to be very different. And they might have other methods. Or other variables that might be working to help determine how those methods would work. But by having abstract methods that have the same name, then any one of these subclass objects, car, boat, or plane, you could call the method move or fuel consumption, and you would know that it had code defined for it. I know this is really out there, and I promise it's all going to come together as we move through the chapter. However, for right now, it definitely is a pretty abstract topic. All right, abstract methods. So, like I was talking about before, usually a subclass of an abstract class will provide implementation of those abstract methods. If it doesn't, and the abstract method is inherited, which it is, then the subclass is also abstract. Okay, so it's important to know that abstract methods must be overridden, and if they are not, then that class itself is also abstract. And one other last little tidbit, an abstract method cannot be made static. And the reason why is because static methods, by definition, cannot be overridden. However, abstract methods must be overridden. So if it were abstract and it had to be overridden, but it wasn't able to be overridden, do you see where I'm going with this? It's not possible. So basically, let's kind of sum this up. Abstract classes are created to give you something to build off of. You don't use those methods directly unless you create a subclass of the abstract class and override the methods. All right, we're going to stop here, and tomorrow we will work through this some more in class. Have a great day.